Introducing 5'8" math teacher from Muskogee, Mr. Freeman. And now he has for you some geometry and lollipop geometry. Alright, I'll stop that. I figured I'll start off today with a little intro music to get our minds ready to not even pay attention to whatever I say. But just maybe you will. Just let the beat go. Oh yeah. Do y'all even remember this song? Classic. Okay. Sorry, Lil Wayne. No more lollipops in here. Okay. Today, we shall talk about using similarity for triangles. I'm putting two units together, or two sections together. First of all, we're going to start off with a postulate and a theorem. Alright? So we got this angle-angle similarity postulate. If two angles of one triangle are congruent, so the angles have to be congruent again, to two angles of another triangle, then the two triangles are similar. Notice that these are different sizes, but we can use the angles to say, yeah, those two triangles are similar if two angles are congruent from one to the other triangle. And this theorem says, using side-side-side similarity, which is different from side-side-side congruency, if a corresponding side lengths of two triangles are proportional, then the triangles are similar. So what we have here is AB, this side over this side, and BC over ST, and CA over TR. If those are proportional, meaning once you set them up like this, they're all equal when you simplify, then you could say that they are similar. Remember, this is a similarity statement. Triangle ABC, one wavy line, is similar to triangle RST. Alright? So, one more. There's side angle side, and some of these sound real familiar. Please don't get these confused with congruence. We're talking about similarity. In congruence, the sides and the angles have to be equal or congruent. In similarity, the angles have to be congruent, but the sides have to be proportional. So in side angle side similarity, if an angle of one triangle is congruent, x congruent to m, to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional. So that means, again, in order to do side angle side, you have to remember that the side and the angle and the side have to be together. The angle has to be sandwiched in between. So that's why in this one they're only talking about ZX and XY and MP and MN, because these are the only sides that sandwich the angle. So ZY and PN don't have an option in saying side angle side similarity. And so here's kind of like a summary of all of them. Angle, angle, side, 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 and side angle side. Okay, so here's like right here is just a similarity of what each three of those. So we got three options to prove triangle similarity. Either angle, angle, two angles are congruent, side, 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 if all the sides are not congruent but proportional here, and side angle side, which means you have one congruent angle and the sides that sandwich that angle in between are not congruent, which those mean congruent, so I shouldn't be doing that, but you get what I'm saying. Those are the sides that sandwich that angle, and their ratios are proportional. Alright, so let's take a look at that and try to get some examples in. Determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. Alright, let's see if we can kind of do some of this. Okay. Now, looking at this particular problem, what we notice, or what you should notice, is that we have two triangles, but they're not the same. They're kind of rotated. And so the first one looks like this, and the second one, if I rotate it down, it'll look like this. So the first one, you have B, A, and C, and this angle right here is 68 degrees. And in this one, this angle is E, this is F, and this is D, and this angle up here is 22 degrees. Okay, so how can we prove that these two triangles are similar? Well, we don't know anything about the sides. We don't have any value, so we can't do anything with the sides as far as trying to find the ratios or the proportions. So what does that do? That excludes this side, and it excludes side angle side, because we don't know anything to say that they're proportional. I hope y'all understand what I'm saying. I don't know a number here, so I can't talk anything about the side. So it has to be angle. But how do I prove that? Well, this angle down here is 68 degrees, and this angle up here is 22 degrees. So what can we use? Yes, the triangle sum theorem that says that this angle has to be 68 and this angle has to be 22. Why? Because all three angles of a triangle add up to be 180, or you could say, since this angle is 90 degrees, those two have to add up to be 90 as well. So we can say that triangle ABC is similar to triangle, and you got to go in that same order, DEF, and the reason why is because the angle postulate. All right, that's the similarity statement, and that's the reason why. Example 2 is either DEF. Let's go back bigger. Is either triangle DEF or GHJ similar to triangle ABC. So here's ABC right here, and let's see if any one of these triangles are similar. All right, and so let's see if we can make this a little bit bigger and scroll down just a little bit. All right, now here's triangle ABC, and if I want to try DEF, well, the first thing I need to do is maybe flip it back up, because triangle DEF is kind of off a little bit. And so if I flip it up, I can't draw really good, but if I flip it up, it'll be D right here, it'll be E up here, and F right here, which DE side is 4, DF side is 8, and EF side is 6. Why did I do that? So I can match it up with this triangle right here. Okay, so I'm going to see if their sides are proportional. I don't know anything about the angles, so I'm going to see if they're proportional. All right, so let's see if I do 8 over 4. What am I doing? I'm doing BA over DE. All right, 8 over 4. Does that equal, let's see, 9 over 6. Does that equal also 8 over 12? Or should I say 12 over 8? Alright, when you look at each one of those, you can tell that this is not proportional, because this equals 1/2, this equals 3 over 2, and this equals 3 over 2. So those are not proportional. It's not going to work. Let's try ABC and this triangle right here. So I think it's set up okay, where I can say, using these two here, I can say 8 over 18. Let's try that. 8 over 18. Does that equal 9 over 16? Does that equal, okay, no, it kind of skipped there, but I went ahead and set them all up. 8 over 18, the corresponding sides, 9 over 16, 12 over 24. And again, we see once we reduce these that neither one of those are similar, because the sides are not proportional. All right, each one of those should have been the same, reduced fraction if they are. All right, so neither one of these are similar to triangle ABC. Now, number 3 here asks us to find the value of x that makes this statement true. Triangle ABC being similar to triangle, DEF. All right, and so what that means is I want to set up a proportion based on true relationships. So maybe I can say something like x minus 3 over 10 equals 20 over 2x plus 3. All right, I hope y'all understand what I just wrote down. This over this equals this over this. But I have a problem here, guys. I have to cross multiply. And whenever you cross multiply here, you're going to have x minus 3 times 2x plus 3. We haven't talked about doing this yet. You may know how, but we haven't talked about multiplying things like that. So I suggest that whenever you have problems like this, that you don't set up proportions that have you multiplying variables. So I'm going to show you what I would do. All right, for the sake of time, I went ahead and wrote it down. I did this side over this side of this triangle, but I matched it up with this side over this side. Why? Because those two don't have a variable that I would have to use. So I took this side over this side equals this side over this side, and that's where I have x minus 3 over 4 equals 20 over 10. I hope y'all understand what just happened here, because I just showed you how you don't want to set it up like this. Just find one variable or have one expression. So this actually equals 2, right? X minus 3 over 4, and that equals 2 over 1. When you cross multiply, you get x minus 3 equals 8. Why? Because 1 times x minus 3 is just x minus 3. And then 2 times 4 is 8, cross multiplying. If I add 3 to both sides, that's x equals 11. All right? So you can check that. You can actually put that in. If I had the time, I could show you where 11 right here would be 8. And so if this was 8, you can set up all kinds of proportions. And 11 right here would be 25. And so all these will reduce down to equal the same thing as a ratio. But x equals 11 here. Now, this example 2 says, tell what method you would use to show that the triangles are similar. Every time I see, let's see, I don't know anything about the angles, or do I? These are vertical angles, right? So that means those two right there got to be congruent because you got that x going on, right? And now let's see if the sides are proportional. The only way it can be side angle side, because that's the only option. I don't know anything else about any other angle. The only way it can be side angle side is if we have proportional sides. So let's say something like 9 over 12. That's a correct one. Those two correspond to each other. And since I started with this triangle, I got to say 18 over 24. Now, if these are the same ratio or equal to one another, then we could say the triangles are similar. So 9 over 12 is the same thing as 3/4. And 18 over 24 is the same thing as 3/4. So what does that mean? That means triangle RPQ is similar to triangle RTS. And the reason why is side angle side. Because I knew those two angles were congruent based on the vertical angles. And then this side, QR over RS, was proportional to PR over RT. And so since it was right here, they are